Okay, so let's start placing components on our PCB. So what I'll do is I'll lay it out in similar way to what I've done in the schematic. Obviously, it doesn't have to be exactly the same. You have to find some sort of logical layout which works for you. What I'll do is I'll place my USB connector first, and by placing connector, if I go in and start selecting different elements, you can see that I can select text, I can select different elements of the actual footprint. So to avoid that, I'll just use escape. I want to turn my selection off. So I'll turn everything off. I'll turn on my footprints. That way I can only select footprints, I cannot select anything else. And that's the easiest way to actually place and move components. The other setting is we've got 5mm snap, which is way too big. So I'll change that back to 1mm for my component placement. You can use 2.5, 1, whatever you prefer. 1 is usually fine. And now placing components as simple as select and then drag and drop. So I'll just drag it over here. I want to rotate it the other way around because obviously that's the entry of the connector is currently on the right hand side. So I'll just press R to rotate, R again, that's my orientation, and I'll place it sort of close to the edge, but this connector is it's fine, doesn't have to stick out, and sort of below a little bit, so I've got some space on the top. Now you can utilize this space any way you want, but what I want is I want to put in my FTDI chip close to my pins, so create a relatively short path. And if I just zoom in, you can see that VBA. So this is the two communication pins. They are actually going through some resistors. So let's have a look at some resistors. 330. We are looking for small values. R1, R2. We can actually check on our schematic, and this is R3 and R4 in my case. So I'll see if I can find them. I think this is R3, yes, and R4 is right there. So I'll use Control to select both of them, and I'll move them here somewhere. Now, so we do have FTDI chip. We've got our resistors. You can see that communication line goes from those two pins through resistors into those two pins, which means that to make it effective, we want to rotate that chip. So I'll just select that chip, press R again, and this is my sort of initial orientation. Now I'm not going to finish my layout as yet because we do have a little issue with that chip, but I'll just place it here and leave it here for now. Next, I'll see if I can arrange my main microprocessor and the pins, the pin headers. So I'll just place microprocessor here somewhere. I'm not sure which orientation yet, so I'll just place it roughly here. Now with pin headers, I have to look at, let's have a look at our micro, if this is the right orientation. We've got our TX line here and RX line here, which is on the top. It sort of works. It's, you want to keep the flow. You want to keep this as short as possible. So I would say, yeah, we'll keep it this way. So I won't be rotating my microprocessor. But if you look at your connector, obviously we need to rotate it. So I'll just press R to rotate it. And this one connects to, majority of those pins connect to this side of the micro. So I want to keep it on this side. Also, we've got some which connect there, we've got some which cross, so we are fine pretty much. So this is our position roughly. Next connector, that connects to the other side. Now we want to put it on the top, so what I'll do is I'll just rotate that and it'll be probably beneficial to flip it to the other side. So I'll rotate it twice again. That's better. What I'm looking for is always to have most direct connections to majority of the pins. You can see that majority of them connect directly. Some of them obviously connect indirectly, and just to make it easier, each of those connectors, this is pin 1. So the last 2 pins is 5 volt and ground. So we are keeping it the same across all different connectors. So just to make it easier, so we don't see all those nets there, those connections, because just to make it clearer, what I'll do is I'll go to my nets on the right hand side, and I'll switch off my 5 volt, and I can switch off my ground. So they're not visible, they're still there, they're not visible, and that will just make it easier to establish my shortest paths and position of all those connectors. Now, next one, that one is on this side, so that's fine. And the next one, this goes to our LEDs. It's completely independent from the microprocessor. So it'll go somewhere in this area. I'll just place it here roughly. And then we've got the programming connector. That's a big one, so I'll move this one. Now, if we zoom in, majority of pins connect to the bottom pins right there. There's one which comes right across there, and the one which comes across is a reset pin. Reset is the least important pin. We're going to wire it absolutely last. It's not something which you have to worry about positioning right now. So all the other pins are connecting across there. So that's sort of a good positioning for it. It's not exactly the right spot, but it's roughly in this area. Now we also have a switch which is quite large. This is for the reset, and I can sort of rotate it maybe. Oh yeah, I'll just rotate it this way, and that's fine. I'll leave it here for now. And then we've got lots of small components. So let's start with the ones which are easiest to reposition. We've got lots of capacitors. So I just double clicked on it. So all those capacitors, I just want to put them aside there because realistically, I'm not going to position them yet. V6. We also have all those values, which we will switch off later on. We don't need to see them on the actual layout. Okay, now diodes. We've got a couple of diodes which are dedicated for our RX and TX lines, and we are talking about D1 and D2. So what I'll do is I'll move my D1 over here, D2 over here, and I'll just, which are linked through a couple of resistors. You can see that they're trying to link into those 2 resistors there. So they form like a little system. Oops, cancel. When you double click, you go into properties, and this is where I went accidentally. And what I'll do is I'll position them, because this is my RX TX indication. I'll position them here somewhere. Now, obviously, I can reposition them later. You can see that they connect to those 2 pins, so this is a good location for them. Also, if you look at the actual board, you're connecting your USB through here, and then you're monitoring your communication, and those 2 LEDs are flashing, telling you which way the communication is going. So it's reasonably good position for them, I guess. What else do we have there? We've got the 4.7. This is the 1, and this is the power. So this is our V-bus power. So power is coming through there. This capacitor is definitely needed here somewhere. Maybe I'll just change orientation to vertical just to save some space. Then we've got C1, which is just a small capacitor also within that circuit. So C1, let me see, C1 is over here. I'll just move it. VBus, that's all right. Rotate, and I'll just leave it here for now. What else do we have? We've got those two. We still need C4, which is our capacitor of 3.3 volts. So C4, I can move that to, don't know where to put it yet, but I'll just leave it here for now. So this is coming to 3.3 volts. You can see actually when you zoom in, you can see that pins have actual net names there. What else do we have? We've got R5 and R6. I'm just looking at a schematic. R5 and R6 are connected to our reset line. So I'll just put them aside. Don't know where they go yet. But yeah, this is our reset pins. This is our reset circuit here. Actually, no, this is ADC. That's not reset. That's not reset. This is the ADC line. Sorry. so those two, I'll just select them, and they'll be somewhere in this area, I guess. What else do we have? We've got C9 and R7 next to our switch. So C9 and R7. Okay. And at this stage, I don't know where they're exactly going, but I'll just move them close to our switch. Okay. Then we've got some capacitors, decoupling capacitors next to our processor, and also next to our FTDI chip. So FTDI chip, I'll just use C5 there. It doesn't really matter which one you use, but so no, C5 is already there. C4, no, C5, okay. They're all the same, so it doesn't really matter. But I'll just move it here somewhere. I know that it needs to be near that chip, and I'll arrange it later. C6, 7, 8, and 10. So 6, 7, 8, and 10. Oops, cancel. They'll be near my microprocessor somewhere, so I'll just place them here. And here somewhere. Now, obviously, at the moment, you've got those nets going through components, and it's a bit of a mess there, but you just need to organize your components somehow. You've got to arrange them first, and then you start moving them exactly into positions you want them to be. So, ferrite bead, obviously near power supply somewhere. And then we've got LEDs, we've got this, yeah. So the rest of it is pretty much LEDs. There is this one capacitor here, C2. Where's it trying to go to? Okay, oh yeah, it's coming to go to in between our shield and ground coming from USB. So I'll just rotate it straight away. So it's got to be here somewhere. Okay, now the rest of it is LEDs. So let's just place them in a reasonable distance from each other. So reasonable distance really depends how close how close do you want to have them. If you make them this close, obviously that's way too close. Even from a manufacturing perspective, that's no good. Well, it's possible, but it's very, very hard. So spread them out so you can tell which one is which, but don't spread them too far. Okay, so we've got the 7, 8, 9, 10. So I'm using 1mm snap here to make it easier. And then 3 will go on the top there somewhere. So hold on, I'll just move those down. So this is 6. This is 5, 4, and 3. Okay. Now we need to arrange our resistors. And okay, so let's start with R8. Oops. And we can just align them together, so they're going from one to another. Direct connections there. It's going to make it easy. Make sure that they are in the correct order, consecutive order. Cancel. When you double click, it gives you that property window. You can just ignore it, close it. Oh, cancel again. I'm too quick with my clicks. Okay, and now we can position it here somewhere. So I'll just select all of them, and I'll drag them into the position. Now it doesn't really matter. You can make it, centrally positioned here, or you can put it higher up. Entirely up to you. I'll use sort of reasonably central positioning here. And this connector, you want those connections to be, reasonably aligned. You can't have them completely aligned, obviously, unless you use much smaller components. But that connector, I'll see. I'll just align it with the bottom here, and that's fine. It's up to you how you align it. Now, so just looking at this layout, we are a little bit too tight in the switch area, so obviously we can fix that. We are reasonably tight here, but yeah, we'll see. We probably don't have to run too many tracks through there, probably nothing. Maybe power. I'll probably run power through there. So I'll zoom in, save it, and now we can start arranging them exactly, putting them into more precise locations. Just looking at the, where the tracks are going to be and how we're going to reshuffle everything to make it work better. So. What's next? Let's just start with this end. There's one little issue here, and we spoke about this issue before. You see the RX and TX lines, they're crossing when they're coming into the microprocessor. This is not a good situation because you really want those two lines to be on same side of the board. You don't want to cross to the other side of the board. So ideally you want them to run in parallel from this point to that point, and that's it pretty much. So if they're crossing here, that means that you really need to swap those pins. Normally with a lot of microprocessors, you can actually assign pins to be either RX or TX depending on the microprocessor. With this one, you can't do that, which means that they're fixed. You keep them as they are. Alternatively, you could just wire this into any two general input-output pins, and then you can communicate using software. It's much better to use built-in RX-TX functionality, so we're going to do that. So what I want ideally is, there's not much I can do on this side. So the only thing I can do is swap those two pins. And then on this side, we've got a little bit more room to move because we can either come off this pin this way or come off this pin on the inside of the chip. if we come to the inside of the chip, we're automatically swapping those lines, the position of those lines. So I'll fix this first. I'll save this. I'll go to my schematic. So let me open this one up. Make sure that schematic is up. Okay. And on my connector, RxTX, where is it? Yeah, right here on top. I want to swap those two. Now, normally, you want to avoid swapping those pins because you want them to be consecutive. So, which means, you know, this is the general input-output D2, 3, 4, 5, 6, 7, and so on. You want to keep that order. It's just much easier to map it when you're working with the board. But in this case, we don't really care if this one is TX or this one is RX. They both just pins coming from, depending where you're coming from. So in this case, what we did is we've got the transmission pin number 1 coming out, and we marked it TX. Receiving pin number 5, we marked it RX. And if we look at the microprocessor, our RX and TX, they actually, our transmission from the FTDI chip comes into receiving pin of the microprocessor, and then receiving pin comes into transmission, because you've got to have them crossed like this. Which means that technically those names, you can name it whatever you like. You could name it, TX-RX and this one RX-TX. To indicate that this is communication left to right and this is communication right to left. Whatever you want to do, it's fine. So in this case, those two pins, that pin is either receiving pin on one end and transmitting on the other. So really, it doesn't matter, we can swap them. This is not something which will affect that circuit in any way or form. So let's get to it. I'll just select and delete those two connections then, and I'll swap those two positions and reconnect them. Okay, so I can save that and I can re-export, and the software will probably handle it anyway, but just in case, what I want to do is go File, Export, Netlist, and just refresh it pretty much. So I want to keep the same name, save it. Done, so that's refreshed. Minimize this. I'm going back into this layout, and now I can just update changes. So update PCB from schematic, click there. Update PCB, we want to relink footprints, delete, replace. We don't want to replace anything, delete anything. We just want to relink them pretty much, or let's try nothing and see what will happen. Update PCB, yeah, anything has swapped. So we didn't even have to use those options. Close. So now we can see that TX goes to this pin, RX goes to that pin. RX, TX, we've got lines are not crossing on this side, but they are crossing on this side. So what we'll do is I'll just select this component, press R, and use this orientation. What this will allow me to do is press start. We can still connect it directly from those two. You can see that they're not crossing, R3 and R4. And then on this side, we can just come out with our RX to the inside of the chip and then connect it directly. That way we are completely, we are starting on the bottom here. That connection goes across. We've got no lines crossing. So yeah, that's pretty good arrangement there. Those two are fine. This chip, we can make a little bit more space here just in case. Put it a little bit higher up. Those two, I'll just rotate them and probably put them next to each other. So what I'll do is I'll just put this one maybe here, that one next to it. Is the spacing okay? It's reasonably okay. We can space it out a little bit more. Now we still have the 5 volt, which is this pin here. So this component, we switched off the actual net so we can't see it, but if I just rotate it, this capacitor should be close to that pin. At the moment, we don't have to worry about it, so I'll just move it up a little bit, but it'll be roughly in this orientation, in this positioning. Now 3.3 volts. Ideally, I want to have it here somewhere, so what I'll do is I'll rotate it, and yeah, maybe what I'll do is I'll just place those 3 together. So this is 3.3 volts. You do want to have it close to your pin, but in this case, we're not using that pin, we're not using this 3.3 volts. This is just to create a stable pin. So that track length is not an issue. That one is probably more important to be close to 5 volts than this one to 3.3 in our case. Anyway, we can leave that. What else do we have? We've got our V-bus, which has to come down somehow and run across through this chip there. I'll make this up a little bit. This one across, maybe. We'll see. We'll see what will happen. This connector here, that's fine. I'm just a little bit mindful for space. I would like to create a bit more space on this side. So maybe I'll push everything across a little bit. But it's very hard to actually say where those components should be initially. Some space here. This is a little bit tight on this side, a little bit too tight. So let's just move everything across. Okay, that on the bottom here, we can move it maybe a little bit closer. That's it. This connector there, there's nothing happening on this end, so I can move it a little bit closer. And that one, this one, technically, if we, yeah, that looks about right. Microprocessor, I'll probably move it in across a little bit. I can squash this a little bit and push that connector in a little bit. That connector there, yeah, I can't see need to have anything running in this area, so that's fine. That switch, can space it out a little bit. And those two, actually, when I think about it, I'll push that switch back. And R7, okay, let's have a look. That reset, we want to have it close to 5 volts, the 5 volt rail. Yeah, we'll have a look at it later on. So initially, I think I'm happy with this layout. I'll break this recording into small sections, so that's it, and then we'll start actually wiring everything up. So save this, and I'll stop this recording.